Okay, I want to talk about inverse of a function. F of x stands for a function, and f of x with a little -1 here stands for the inverse of a function. So let's take the function x plus 4, and its inverse is x minus 4. Now, one thing you can do with functions, if you put an inverse into a function in place of the x, or the function in place of the x and the inverse, that's a test. And if you come out with x as the answer, you know that one function is an inverse of the other. So let's take the f of x function, which is x plus 4. And in there, I'm going to put the inverse function, which is x minus 4. So watch what happens. F of x equals, I'm going to replace the x with x minus 4 plus 4, and I get x. That means that one function is the inverse of the other. All right, let's go backwards here. Let's try the inverse function, which is x minus 4. Let's put the function in there. And if the function is an inverse of this, then I will get x for the answer. So let's do it. In place of that x, I'm going to put the original function. So x plus 4 minus 4 equals x. So that's a true test of whether a function is an inverse of another function. You can take either one and put it in place of the x in the other one and try that. So I want you to try that on your homework while you're working on inverse of a function. Okay, I got two more functions here to talk about in terms of inverse of a function. If you graph two functions, their inverses are mirror images about the y equals x line. So if you graph this one on your graphing calculator, you'll see an interesting little curve, which goes through here. Let's see, where else does it go through? It goes through 1, and then it crosses like this and goes down like this. That's the line, the cube root of x plus 1. What I want you to do is take your graphing calculator and graph both of these. And then you'll be able to see that they're mirror images of each other. And then we can check if they're inverses of each other. One way, which I showed you a few minutes ago, was to plug one into the other. Another way is to do 4 steps. The first step is replace f of x with y. The next step is to switch x with y, and all of the x's with all of the y's, and vice versa. Step 3 is solve for y, and step 4, replace the y with the f inverse notation, because you found the inverse. So let's try that. F of x equals cube root of x plus 1. All right, replace f of x with y. So step 1, y equals cube root x plus 1. Step 2, switch the x's and the y's. So x equals cube root y plus 1. All right, step 3, solve for y. All right, to solve for y, I need to get inside of there. So I'm going to cube both sides. So I'm going to do x cubed equals the cube root of y plus 1 cubed. That gives me x cubed equals y plus 1. So that's step 3. What's step 4? Replace the y with f inverse of x. Oh, solve for y. I didn't finish, did I? Move the 1 over. So y equals x cubed minus 1. Step 4, replace that y with f inverse of x. Equals x cubed minus 1. Look, I got the inverse, so that's right. Now you can also do the test with this. Do the 4 steps with this one, and you should get that. The second thing you can do, graph them, and they should be mirror images of each other on the graph, and check them on the graphing calculator. If they're not, either one of your equations is incorrect, or you did a typo when you're putting it into the graphing calculator. So be careful. But that's how to find inverses using algebra. All right? There you go.